Next is question number 7. It tells in the network shown in figure, the switch closes at t equals to 0. The capacitor is initially uncharged. Find Vc of t and Ic of t. Diagram given is 10 volts, 10K, 4K, 4K, 1 microfarad. You can say at t equals to 0 minus, the switch will be open. So the circuit will look like this, and there will be no voltage induced across the capacitor. So we can say it will be shorted. This switch is open. Vc of t is across this and Ic of t is flowing through this. So since it's open circuit, both Ic of 0 plus and Vc at 0 minus will be 0. So we can say Vc of 0 minus is 0, Ic of 0 minus is 0, and the same conditions will be revealing at 0 plus. So I can say Vc at 0 plus 0 and Ic at 0 plus is 0. Now I'll draw the circuit for t greater than 0. But we'll try to find these values rather than writing. I'll try to redraw the circuit, check whether this condition is true. We'll check this condition whether it is coming to be true. This will act as shorted. This 10 volt will come in picture. Now this is Ic of t at 0 plus, Vc at 0 plus, 4K, 4K, 10K, this 10 volts. So from this we can see that this condition is not getting satisfied here. That means Ic of 0 plus is not 0, so we cannot claim this to be 0. So we need to find Ic at 0 plus, right? Then for that, suppose say this is the total current, so I'll try to find the total current. Total current will be parallel of this total supply voltage upon total impedance, 10K plus 4K in parallel with 4K. So total current will be 0.833 milliamperes. Then by current division we can find Ic at 0 plus 0.833 milliampere into 4K upon 4K plus 4K. So this will come to 0.416 milliampere. So what we have proved, even if the voltage is 0, the current may be 0 or may not be 0. So you need to check the condition at t is equal to 0 minus. So in this case, this is going wrong if you are assuming that if voltage is 0, the current will also be 0. So we need to check from the diagram whether we are getting the current. So here we are getting IC of 0 plus at 4.416 milliampere. Now I'll draw the circuit for t greater than 0. For t greater than 0, the circuit will be, switch is closed, you have resistors, and the capacitor now will come in the picture. 1 microfarad, 4k, 4k, 10k, and 10 volts. So you can reduce the circuit. In this case, 10 volts and 10k can be converted to a voltage source in series with resistance, can be converted to a current source in parallel with resistance. So this will be 1 milliampere, then 10k, and then you will have 4k. I'm just drawing the half part. So again, when you convert, it will be 1 milliampere in parallel with 10k in parallel with 4k will give you 2.85 kilo ohms. This is nothing but 10k in parallel with 4k. Again, you can reduce it to a voltage source in series with resistance. This will be 2.85. This will be 2.85 plus 4, so 6.85 k, and this will be, the voltage source will be 2.85 volts. So I have reduced till this part. This entire is reduced to a single voltage source in series with resistance. So I can redraw the final circuit as 2.85 series with 6.85 k, and the capacitor 1 microfarad. So how the circuit is reduced, you have IC of t flowing through this and VC of t across this. Now if I apply KVL in this, KVL to the mesh, it will give me 2.85 minus 6.85 k I of t or IC of t minus 1 upon 1 into 10 raised to minus 6 integral 0 to t IC of t dt is equal to 0. So I am differentiating this with respect to t, differentiating 1 with respect to t, it will give me minus 6.85 k di by dt minus 1 upon 1 into 10 raised to minus 6 I of t is equal to 0. IC of t is equal to 0. So I can say di by dt plus 145.98 IC of t is equal to 0. So this is our standard form. Writing the equation again, di by dt plus 145.98 IC is equal to 0. So we can say I of t is equal to C e raised to minus pt, so minus 145.98 t. So now we can find the value of C. I at 0 plus we have found it as 0.4165 milliamperes. So C will be 0.4165 milliamperes. So we can say IC of t is equal to 0.416 into 10 raised to minus 3 e raised to minus 145.98 t amperes for t greater than 0. So this is how we have got the equation for IC of t. Now we can find VC of t by integrating from 0 to t. So it will be 1 upon 1 into 10 raised to minus 6, 0 to t. Then the same equation 0.416 into 10 raised to minus 3 e raised to minus 145.98 t dt. So you will get it as 0.416 into 10 raised to minus 3 upon 1 into 10 raised to minus 6 e raised to minus 145.98 t upon minus 145.98 plus c, or you can say Vc of t will be minus 2.84 e raised to minus 145.98 t plus c. Vc at 0 plus is 0, this will be 1, so I can say c will be 2.84. So when you substitute c as 2.84 in the above equation, Vc of t will come to minus 2.84 e raised to minus 145.98 t plus 2.84. So if you take 2.84 out, it will be 1 minus e raised to 145.98 t. This will be Vc of t for t greater than 0. So this is how I have first found IC of t, and then from that I found Vc of t. So both things can be asked in the same question.